Hello everybody, this is part 2 of our training on relay logic for motor operation. In part 1 we discuss the component and symbol we use in relay logic operation, and we'll give more discussion about the auxiliary contact relays and contactors. And we have two different case studies. First is direct line start of three-phase induction motor. And as we discussed last time, we have two main circuits in relay logic: the main power circuit and the control circuit, and then reversing motor direction. Uh, that's the end. Okay, end of part one. Okay. Today we'll talk about star delta starter for three-phase induction motor. The problem of induction motor, as we mentioned before, it has a high starting current. It's around from 6 to 10 times of its rating current. So, for example, if our motor's rating current is 10 amps, so we expect a high starting current vary from 60 to 100 amps. This will depend on the load condition of the motor and the motor itself condition. Okay, the equation here is the starting resistance or the stator current of the motor. Okay, at the starting up is the main important part in this equation is the rotor resistance. We can see here the rotor resistance is divided by S. So this is our since the rotor resistance depends on S value or the slip value. So at starting up we can S is equal to 1. This means if we go back to this equation, the equivalent rotor resistance is minimum. So let's have a better thinking about motor at starting up. S is equal to 1 and the rotor resistance is equivalent to 1 ohm, or the rotor resistance 1 ohm. So starting up rotor resistance will be 1 ohm. Okay, if the motor operating at speed near as close as possible to its rated speed, and S in this case equal to 0.1 ohm, this means the rotor resistance will be around 10 ohm. So at high speed the induction motor takes much less current than the current it takes at low speed. Based on this equation and based on our understanding of the effect of the motor slip. Okay, so the problem is at starting currents F equal to 1. Okay, this will cause so if we excite at full voltage, if the motor connected directly to the three-phase bus bar once, the motor will absorb a high starting current as we discussed before and develop high starting torque. The problem of this suddenly high starting current it has two main issues: or two side effects, or mechanical equipment such as hammering on fluid pumps, or electrical utility. So it can cause voltage dips and unstable operation in working power sources. So if our induction motor supplied from, for example, three-phase or standalone diesel engine, it will have unstable operation during starting up. Or if we connected to strong grid, a large starting motor current, the large may cause a voltage dips. Okay, in order to be able to reduce the starting current, starting voltage has to be controlled. Okay, we have two ways to control the starting voltage: electromechanical, like soft starter, such as we can add resistances in series with the motor, and we remove the resistance in fixed steps until the motor reaches its rated speed. Another way we can use auto transformer. So we don't give the we will not supply the motor suddenly with its full voltage. No, we'll have a ramp increase in the motor voltage. The final way is the star delta starter. This is our main topic today. Okay, or electronic soft starter such as AC voltage controller or V over F starter. Okay. To understand the effect of star delta starter, let's have this case study. We get our three-phase line voltage. Let's say the line voltage is 380 volt. 380, sorry, 80 volt. The motor winding is connected in star 4 or in delta. Okay. If our motor is connected in delta, in the other case, our motor will supplied by the same three-phase winding, but the motor winding is connected in star 4. Star 4, the final part. Okay, same thing, the line voltage here is 380 volt. Okay, let's see what happened. The winding in case of delta connection, the phase voltage will equal the line voltage. This is a problem. So the phase voltage equals line voltage, so the winding will face 380 volt. Okay, if it connected in star formula, so the voltage here we call it V phase will equal the line voltage V line over root 3. So what this means? This means that our motor will have the winding will face will have a less voltage. So by 1 over root 3, which is 58% less. This means that in case of star connection, the starting current will reduce by 58%. Why? Because in case of connected to direct online in delta form, the phase voltage will equal line voltage, so that we have very high starting current here. But in case if connected in star form, so the line each winding will phase the phase voltage, not the line voltage, and the phase voltage is less than the winding voltage by 1 over root 3. So in this case, our motor we must have the fixed terminals of our motor, so we can connect it rather than star or delta. Okay. The star delta starter is suitable for motors in range from 15 to 30 horsepower. We can use, if we have motor higher than, it's preferred to use AC voltage control or V over F control, or which we call variable speed drive. Okay, relay logic example 3. Draw the power and relay logic circuit of motor control center that can be used to fulfill the following functions and use EKTS to simulate your design of star delta starter of three-phase induction motor using on delay timer with indication lamps. Okay, let's see our design. As we use also we have our power circuit and control circuit. So let's have, starting by our power circuit, we have circuit breaker to protect our motor from short circuit or any interruption, the overload. Okay, contactor 1 will connect the power to our motor and our 6 terminals 3-phase induction. Okay. We have now contactor 3 and contactor 2. Contactor 3 we use it for star connection, and contactor 2 we use it to perform our delta connection. Okay, let's see the job of contactor 2. Just in case if we have this is our three-phase winding of our induction motor. If I want to connect this winding in star formula, I just short the end of the 3 winding. Okay, let's see. W2, U2, V2 are, once contactor 3 is activated, they are shorted. So clear, no problem. Okay, let's have a look in delta winding. So we have our 3-phase winding. This is U, V, and W. Okay, we can write here U1, V1, W1, U2, V2, and W. Let's have a look what happened here. V2, okay, let's start. U2, if this contactor activated, it will be connected to V1. So U2 to V1, and V2 will be connected to W1, and last for sure W2 will be connected to U2. So by this way, once contactor 2 is activated, we'll get our delta connection. Now let's summarize our power circuit again. We have our circuit breaker, contactor 1 to connect our circuit, overload, overload relay, and our 6 terminals 3-phase induction motor. Contactor 3 we use for delta connection. Contactor 2 we will use it for contactor 3 used for star connection. Contactor 2 will use it for delta connection. Let's go to our control circuit, starting from the line to the neutral point. Okay, first we have the fuse, the overload signal. So in case of overload, the overload will change its auxiliary contact situation from normal close to open, so everything will stop. We have our start button, stop button, no problem. Okay, once the user presses start, the current will flow in this side, so contactor 1 will be energized. Clear? Okay, in same time, the timer will start counting for 20 seconds. Timer 1 will start counting for 20 seconds, and in same time, contactor 3 will be activated. Very nice. So the timer will start counting, and the motor is now in a start connection. For sure, lamp 1 will be on, and lamp 3 will be on. Okay, 1 second, 2 seconds, 3 seconds, until we reach 19, 20 seconds. 20 seconds happen. Contactor, the relay will, the timer will trigger. It's on delay timer. This one on delay timer. On delay. Sorry. On delay, so the contacts will change its state. This one will be open circuit, and this one will be short circuit. By this way, contactor 2 will energized, and contactor 3 will be energized. Okay, we have two protection in our circuit. First one, the mechanical interlock between contactor 3 and contactor 2 to prevent having a short circuit in the supply terminals. Also, extra protection we done. We have interlock in our control circuit between contactor 1 and contactor 3. So if contactor we have, and also we have a protection in our control circuit between contactor 2 and contactor 3. So if contactor 2 activated, contactor 2 is activated, contactor 1 will not be able to activate. It's wrong. Sorry, this is wrong. This is contactor 3, and this is contactor 2. So if contactor 2 activated, this part will be open circuit, so contactor 3 can't activate. And if contactor 3 activated, the terminal will be open circuit, so contactor 2 cannot be activated. Okay, let's go to our simulation software. We will use EKTS, starting by we having our 3-phase supply. Now we'll have 3 contactors, first 1 2 3. This is contactor 1, contactor 2, and contactor 3. Oh, okay, we have our three-phase induction motor. So when we have star delta connect. Okay, and this is our three-phase induction. We need just to wire everything. As I mentioned before, the EKTS software do not simulate the behavior, the control set, only the behavior of our control. There is no protection in EKTS. Okay, so now we need to wire up everything. I would like to have a good line, good wires. Okay. This one is for delta, and now our star contactor. Okay, let's start now our control circuit. We have the line and the neutral. We'll have three contactors and one timer and three leads. Okay, contactor, first contact, 1 2 3, and one on delay timer, and we have three lamps, 1 2 3. Our first lamp rotated by 90 degrees, second lamp 90 degrees, third lamp, our timer, this is on delay timer, and contactor 3, contactor 2, finally contactor 1. Okay, let's fire up everything. I'm just cleaning my wire. I would like to make it look pretty. Very bit more. Okay, now we have our start button, stop button, auxiliary contact. No, auxiliary contact. This is our auxiliary contact. We don't need this one. This is our stop button and our start button. start, stop. Now we need to name the contactor K1, K2, K3, timer 1, lamp 1, lamp 2, lamp 3. Okay, finish the easy part. Okay, the lamps are easy to control, just to copy the situation of each contactor. 1, 2, 3. So this is first lamp. Okay, to indicate the situation of to give indication of contactor 1 situation. But now this one is contactor. Auxiliary contact, sorry. We attach auxiliary contact. Okay. Now we need to make some easy job. This contactor 1. This is auxiliary contact of contactor 1. Auxiliary contact of contactor 2. Auxiliary contact of contactor 3. This is our contactor 1. This is contactor 2. And finally this is contactor 3. Timer. Okay, we need to have two normally closed contact, normally closed auxiliary contact, and one normally open, and one, 2, 3. Okay, first we'll make the interlock between the two contactors. Contactor 1, 2, and contactor 3. We have here 90 degree. This is timer. We need one more normally close. Normally close. Okay. This contactor 3. Now we finish the interlock between the two contactors. Once timer, so we need to attach this with timer 1, and this one with timer 1, and the delay is 20 seconds. Okay, hope everything is fine and it will run. Okay, visit meeting. this will be contactor 1. Okay, let's run. I press start. You can see here the current flow from the contactor 1 and the start connection is activated. The counter, the timer now is timing up the time. You can see here the current flow from here to there, but the timer blocks the current to flow to contactor 2. Now 4 seconds, let's see, 2, 3, 1. The timer change its state and the motor now is in delta connection. Stop and start again. Okay, the start stop is working also. Now let's see, 20 seconds. Once the 20 seconds finished, the timer will change states from normal. The normal flows will be open and the normal open will be closed. So contactor 3 would be de-energized and contactor 1 will be energized, as you can see here. Now our motor now connected in delta. So we give our motor 20 seconds to start up and build its speed. Then we change its connection from delta to start. Thanks a lot for listening and see you in next video. Bye bye.